everyone, here are the 2.3 examples. We're going to start right away here with example A. It says, Jonas drove his car from Montana to Canada while on vacation. While there, he needed to buy gasoline and noticed that it was sold by the liter rather than by the gallon. Use a conversion factor. 1 gallon is about equal to 3.79 liters to determine how many liters will fill his 12.5 gallon gas tank. Okay, so what I would say is we can use proportions to help us solve this problem. And I think that using our units, gallons, and liters should really help. So I'm going to say 1 gallon over 3.79 liters is going to equal, now when I have to set up my other proportion, I'll know exactly what goes where. Because I have a 12.5 gallon tank, so I can do 12.5 gallons over, and I don't know how many liters there are, so let's just say X, because I have L's and G's already, X liters. Okay, so then I can go ahead and solve this one. What I'm going to do is 3.79 liters over 1 gallon is going to equal X liters over 12.5 gallons. Now, could I have set this one up right away just like this? Of course, it doesn't really matter how you set it up. You might want to put liters on top, gallons on bottom, or gallons on top and liters on bottom. It doesn't really matter how you write your proportion as long as the units will match up. Okay, so then I would take 3.79 and multiply it by 12.5. So if I multiply both sides by 12.5, multiply by 12.5, multiply and divide, 12.5s cancel out, and I would be left with, again, 47.375, and my units are liters. So that's how many liters will fill up his tank. 47.375 liters will fill up that tank completely. That is the same as 12.5 gallons. Alright, next example. A radio-controlled car travels 30 feet across the classroom in 1.6 seconds. How fast is it traveling in miles per hour? Alright, so miles per hour, this is distance, and hour is time, right? So when I write this out, I want to have my distance in the numerator and time in my denominator. So I'm going to have 30 over 1.6, okay? And I'm going to have 30 feet over 1.6 seconds. So the question is, do I want to convert feet to miles, or do I want to convert seconds to hours? And it doesn't really matter. We're going to have to do both. It's just which one do you want to do first. So let's convert feet to miles first. So what I want to do is notice how there's feet in the numerator, and I don't have an equal sign, so I want to have it in the denominator, and then I'm going to have miles in the numerator. All right, that way my feet and my feet will cancel out when I multiply these two fractions together. Okay, so how many miles and feet are there? Well, in 1 mile, there are 5,280 feet. Let's not even talk about why feet and miles are more annoying than meters and kilometers, because I don't have enough time to tell you all the things that I don't like about this. All right, so we have this, and I could multiply them, but now let's go ahead, and we would have, this would be miles per second if I multiply this out. And I want miles per hour, so let's go ahead and multiply this by something that will convert seconds to hours. So since I have seconds in the denominator, I want to have seconds in the numerator and put hours in the denominator. And do I know how many seconds there are in an hour? Well, I know there are 60 seconds in a minute and 60 minutes in an hour. So in 1 hour there are 60 times 60, which is 3,600 seconds in 1 hour. Now my seconds and seconds would cancel out, and my units that I'm left with here are going to be miles and hours, which is exactly the units that I want. Alright, so now all I have to do is multiply my numerators and multiply by my denominators to get my units. Alright, so that means I have 3 times 3,600, so 3 times 3,600 is 10,800, and I'm going to divide that by 5,280 times 1.6, so I'm not even going to do 5,280, I'm going to do 1.6 times 5,280, and I get 8,448. So now I just take 10,800 and divide by that. Alright, so I get 10,800 and divide by 8,448, and I get to 1.28 miles per hour. Alright, quick mistake. I multiplied 3 by 3,600, not 30. So that makes my 10,000, 108,000. Oops, that's not what I want to remove. I want to remove this thing right here. Okay, so instead of that, it should be, instead of 1.28, I should have 12.8 miles per hour. That seems much better. 1.28 seemed a little slow, so I had to go back and check my calculations. And it is 12.8 miles per hour, which seems okay for a radio-controlled car. All right, and each of the fractions after the first one has a value of 1 because the numerator and denominator of each fraction are equivalent. 60 seconds equals 1 minute, 60 minutes equals 1 hour, 1 mile equals 5,280. So I have 1, 1, and 1, right? The fractions equivalent to 1 are chosen so that when the units cancel, the result is miles in the numerator and hours in the denominator. The speed 12.8 miles per hour is a rate because it has a denominator of 1. So we're talking about rates in this case. All right, there you go. There are some examples. Good luck with your assignment.